Hello students, welcome back. So as we are studying from module 3, so our part A is of signal generators, and part B is of comparators. Okay. So among this, the first part is completed. So let us start with comparator from today. Okay. So let us start with comparators. So in comparator, the first topic to be learned is zero crossing detector. Okay. So we will be starting with this topic as the part B of your module 3. Okay. Yes. Zero crossing detector. So as the name suggests that zero crossing detector is a detector which detects whenever your input signal crosses zero line. Whenever your input, see, for example, this is your input. Okay. This is your input. When it is crossing zero line is this. Here it is crossing 0, here it is crossing 0, here it is crossing 0, isn't it? So when your input is crossing 0 line, when it is going from positive half to negative half, it is crossing line. When it is going from negative half to positive half, it is crossing line. So each time when it is going from positive to negative and negative to positive, it has to cross 0 line. So we can construct a circuit which can detect whenever your input crosses 0. Okay. So it's not very difficult if you think. See, now I'll be drawing here. It's very simple. This is your normal op-amp. Okay. Plus VCC as it is, minus VE as it is. Okay. These are the two terminals, right? What I will do is, I will ground your inverting terminal. I will ground inverting terminal and let me apply V in here. Input voltage at non-inverting terminal. Alright. Suppose we have given this input. Suppose this is your input. Okay. This is your input. Now, how will be your output? Now see, if you see circuit, there is no feedback connected, right? No resistor in the feedback and there is no feedback. So we can say this op amp is working like it is working in an open loop condition, right? Now let me draw its waveform. If this is your input, this is your input, right? Same input I have drawn here. Dotted line is representing input. Now the output is going to be so since I am drawing output here, V naught. How will be your output? It is when your input is crossing 0. See, it is crossing 0 here. Whenever your input crosses 0, it is here, non-inverting terminal. When this positive half is applied, when this positive half cycle of the input comes here at the non-inverting terminal, your output will switch from minus saturation level from minus and it goes to plus saturation level, and it remains here. Your output remains till plus V naught sat, and the moment your input crosses this zero line again, your output switches from plus V naught sat to minus V naught sat. Try to understand. Your output, now you may be thinking why I have drawn a rectangular output here. The blue line is representing output. Why it is rectangular? It is rectangular because it is representing that this is the maximum possible output. This is the blue line what you see here, the rectangular, this will continue like this. The blue rectangular output is the maximum possible output of this particular circuit. Why? Because we know that this particular op-amp is working in open loop condition, and in open loop condition the open loop gain will be very high, isn't it? The open loop gain will be very high. Now the thing is, if we have given, for example, VCC equal to plus 12 volt, we have given VCC equal to plus 12 volt. What is the maximum possible voltage? What is the maximum possible output voltage? It is going to be plus V naught sat. You already know this. Why it is plus V naught sat? Plus V naught sat. And what is this plus V naught sat? It is always less than VCC. It is V naught sat is always less than VCC. It means we have given plus VCC as 12 volt. Your V naught sat is going to be very near and less than 12, that is 11 volts. We consider it as, we take it as 11 volt, right? So this is the maximum possible output voltage. Fine. And here it is minus V naught sat, minus V naught sat. So let me repeat here. The output produced of this circuit is keep on changing from plus V naught sat to minus V naught sat, minus V naught sat to plus V naught sat whenever your input crosses 0. Whenever your input crosses 0. Now, one important thing to notice here is, whenever your input is going from negative, to positive, see, I will continue it here. It was supposed to be like this, right? If I continue before the time 0, see here, it was, your input is going from negative to positive, means when it is crossing this, when your input is negative, your output is going to be negative. When your input is positive, your output is going to be positive. See here, plus, isn't it? For positive input, positive output. For negative input, negative output. For positive input, positive output. Negative input, negative output. Why? Because input is given to non-inverting terminal. So positive input will produce positive output. Now we cannot say like that positive input is producing positive output. We should tell like this: whenever input is crossing 0 line from negative and going into positive region, whenever input is crossing 0 and going into positive region, your output is going from negative saturation to positive saturation level. And when your input is crossing 0 and going from negative to positive input voltage, your output is shifting from positive saturation level to negative saturation level. This is how you need to tell. Now, one important thing I missed out, that is the 0 line what you see. I have written here 0 volts line. This is our 0 volts line, right? Your output is not changing exactly at 0. This is ideal case. That output changes whenever the input changes exactly, or whenever input crosses exactly at 0 line. But practically, for your output to change corresponding to input, it takes at least 300 microvolts. It takes 300 microvolts amplitude. It means that if you want here, if this is your input crossing 0, it is going from negative to positive, then the moment it crosses 0, your output won't change and become positive. Your output won't become plus V naught set the moment it crosses 0 volts. It should cross this 0 and at least build it, at least it should reach a voltage of 300 microvolts. At least it should reach 300 microvolt, little small voltage, little bigger than 0, little bigger than 0. Then only it will understand that it has gone into positive voltage, hence the output is changed from minus V naught sat to plus V naught sat. And similarly, when your input crosses and goes into below 0 line, that is negative, once again minus 300 will work as the reference line. This is in practical case. This is in practical case. Ideally, 0 line will be acting as your the line which is deciding when the output will change. Okay. This is what zero crossing detector is. Zero crossing detector is what it tells: whenever your input crosses 0, output will change its state from positive state to negative state to positive state. That's it. Okay. So this is your simple zero crossing detector. After this, let us see the next circuit, inverting. So this was non-inverting, right? This is non-inverting. This is non-inverting. For your simple understanding, I started with non-inverting. Now to make this inverting, how should I change? Yes, input is given to inverting terminal and the non-inverting terminal is grounded. I'll draw it here. Inverting zero crossing detector, ZCD in short. Inverting zero crossing detector. See, minus plus I have interchange. This is your V in. Once again input is given. Okay. This is your output V naught. Nothing else is changed, only plus minus is changed. Okay. Rest all as it is. How will be your output? Yes, tell me. If this is your input, right? The dotted line is representing the input. So how will be our output? See, the input is given to inverting terminal, means whenever input crosses 0 line, that is whenever input goes from negative to positive region, this is positive, right? Positive, negative, positive. Whenever input goes from negative to positive, output switches from positive to negative. Okay? Output switches from positive to negative. Like this. Understanding? This is plus V naught sat, this is minus V naught sat. Okay? The dotted line is our input. Just concentrate here. This is our output waveform. The rectangular waveform is our output waveform. So whenever input is negative, the output is going to be positive. I repeat, when your input is negative, output is going to be at positive. And when your input crosses 0 and changes from negative to positive, I repeat, when your input goes from negative to positive half cycle, when this happens, your output shifts from plus V naught sat and comes down and settles at minus V naught sat, minus V naught sat. Understood? Just see here, when your input is positive, you are having an output of negative. Output is at minus V naught sat. Similarly, when your input crosses from positive region and going into negative region, at this point, when you are crossing at this instant, your output shifts from minus V naught sat and it goes and settles on plus V naught sat. So see here, for negative input you have positive output. Understood? And for positive input you have negative output. Why is this? Because you applied input for inverting terminal. Means whatever input you give, the output is going to be inverted of your input. So this is why for a particular input your output is getting inverted to its polarity. Understood? So this is how the zero crossing detectors work, inverting and non-inverting. Okay. Let us take a new topic, voltage level detector or comparator.